So hello and welcome friends to our channel Intro Mech, where we discuss about basic mechanical engineering concepts and many other things which are related to the automation industry. So guys, we have started our new series regarding the special mechanical devices, and in which we are discussing about the Nutrunner systems. You can check out our previous sessions to know more about what are the basics of Nutrunner, how they can be selected for manual machine and semi-automatic machine. In this session we will see like what are the different parameters that are required to be considered for using the Nutrien system in fully automatic system. So without wasting time, let's get started. Now the fully automatic tightening machine with auto screw fitting. So we can see the requirements: design a machine for tightening bolts. The bolts should be fed automatically to the system. Tightening should be done automatically. Now here we can see the requirement. In our manual or semi-automatic machines, the bolts were already pre-inserted and we were only tightening. Now in this fully automatic system, what is the requirement? The auto screw feeding is also required. Now let's see how the machine can be. Now see, this is one kind of screw feeding system. We can see over here. So the tightening module, the feeder unit and the controller. The feeder unit, we can see that will be kind of a feeder in which the bolts of required size will be loaded, and this will be a complete unit from which we will be having the bolt into the mouthpiece, and then automatically it will get tightened. So this is kind of a system we want now. uh, Now let's see how this system works. So the feeding system works. So the screw will come to the mouthpiece, and we can just check like in mouthpiece what will happen. So one screw will get there will be a singling, and this one bolt or screw will travel to the hose and it will come to the mouthpiece. Now you can see when it comes to the mouthpiece, it will get tightened into the system. One screw will come at a time, and then it will get tightened, right? So you can, you might have seen that in the nut runner it has to push the screw, and then the complete system has to move down, and then the tightening will happen. So let's see for this what we require. Again, we have a desorter system, and this is kind of a auto feeding system. Now these kind of systems are customized, and according to our application, these things will get designed. So we will not get the actual things, but we can see what are the options available. So here the screw feeding system, we can see the what are the different accessories and kind of things over here. So we can go through that. Now here it is the main part. Now we are dealing with the automatic station with the auto feeding. So as we just saw, we can see the screws are blown through the feed hose to the loading head. We just saw the animation how it is done. So this will, the mouthpiece and this system will be integrated as a nut runner, and the feeder system will be a separate system. And from the hose, a single screw will come into the nut runner system. So and then it will push and the tightening will happen. So we can have step feeder or bowl feeder. Different types of feeders will be there. We can see what is the different application and specifications, and according to that we can select. It will be having different sensors and all those things. So we can select accordingly whether we want these things or not, right? And then we have the linear rail and escapement. Escapement is nothing but the singling. We have just saw into the video that one bolt, one screw should be there at a one time. Then the automatic station auto feeding, so this is our requirement. So with this we have different type of nut runners available, right? So Let's see what are the different times with or without Z axis head stroke. Then we have um, vacuum option for a hard to reach points, male female screw recess, then best cycle time, all tightening directions. So we will see what are the different types like S1 S2 VS1B VS2B VS2S, so and what they offer. So let's check it out. So here you can just see screwdriver adapter loading head. So a swell loading head, what how it looks, and what does that include. The stroke model will include, we can see the pneumatic cylinders, screw bait, vacuum tube, vacuum module, and guide rail depending on which model we are selecting. So this is the important part, the Z axis head stroke. So single stroke S1, as we saw this S1 thing. So what does it mean? S1, the screwdriver is lifted by the tool cylinder and moves up and down. So you need to supply and control the approach of loading head. So w- w- we require a Z axis over here on which we will mount this single unit. So it will be having only one stroke inbuilt. So in order to move this complete system to our approach space, we need another drive on which we have to mount it. That is the meaning of single stroke. So if in our system we have kind of a Z stroke, some cylinder or servo, we can go for S1. Then the double stroke comes. So besides the tool cylinder, there is additional feed strokes, and that will transport the loading head to the tightening point. So that means it will be having both the strokes. We just have to keep it on some, let's say, X or um, Y axis depending on the location, and we don't require any additional Z axis because it will have two cylinders. One will transfer the complete unit to the tightening point, and then the second stroke will be actually tightening the bolt. So that is the meaning. Then hard to reach points, as we discussed, if there are like a special cases in which there is an interference between the jaws and the product, then we can have additional adjustment as an extension of vacuum tube to avoid the interference, we can see. So depending of on the application, we need to select this Nutrunner arrangements. So that is why it is important to know which kind of system we want, or whether we want a fully automatic, how the screws are getting fade, and how we want to have the tightening. Then extreme hard to reach system, we can have another VS2 VS2B type of system over there. So VS2B. So this will be different options available, and we can select accordingly. Um, then the horizontal or bottom up direction air holding function will be there. So um, depending on these things, we have to select the proper tool. Then the feeder, we can see the screw mixing, this distribution system is there, whether it is one type of screw, we can have one hose. Then different screws distributing mixing is also there. If we are using like a two nutrons, then the distribution system is required. So according to the application, we need to select these systems also, and that's why we should know the types of the bolt or screw, the sizes, all these things will be there. And then of course the different accessories are available, different sensors are available, we can select them according to our need. So this is how we can select the automatic system. Now let's see, we have a different condition. We have a fully automatic tightening machine with screw pick and place. Now it can happen that the screws are at some place and we need to pick and place and then tighten. So what is the requirement? Design a machine for tightening screw. The screws should be automatically picked and placed on the component. Tightening should be done automatically. Now this is the requirement. Now let's see how we can design the machine for this one. So see here, uh, you can you can see the screws are on another system and it is picking and it is placing and then tightening. This is having two nut runners running side by side and automatically. So this is the requirement. Now let's see how we can select. So we have seen this catalog, so let's move on to the important part. So here now automatic station with pick and place. So this is our requirement, right? So we will check in this application what we have: single and double stroke again. Then we have VP0 on your own Z-axis stroke, wide range of screws, then best cost and compact design. So we have VP0, VP1 and VP2. These three options we have, right? So let's check out what these things. So it will be having an additional function as a vacuum that will pick and place, and that is why we require this kind of system. So pick and place, best fit to your request. So let's see what we have. Without the z-axis provided, vp0 is designed to manually used, so it will not be having any z-axis, so it can be used manually. Or required to be fitted on the z-axis, right? This is one option. Then we have again with z-axis provided, we so this is vp0. Then with z-axis provided, VP1 needs to push on customer part to tighten. Now see, this is the thing. We need to know what is the material of the part, whether the customer is okay to push uh, on to the part or not. So that is kind of thing we should know, and then we can select the system. So this is with the z-axis provided. VP1 is with the z-axis provided, but it is pushing onto the customer part to tighten. And then what we have, the third option is with the z-axis provided an additional stroke, so vp2 can tighten the screw without pushing on your part. So that is one thing. So it will be having another z-axis for additional stroke, which will help in not pushing the uh, which will help to tighten the screw without pushing onto the part. So this is will be the third option available. So according to that, we can select the system. So more basically for pick and place, it will be having some vacuum management, and you can see the tube which will pick the screw. So according to that, we need to select the model. So this is VP2. Now we don't require any feeder over here, right? uh, we are picking and placing the screw from that part, from the customer part only. It will be placed at some mechanism as we saw into the machine. So this will be like a automatic station pick and place. So we need to check the catalog properly, and we need to see which kind of system we want, because here you can see the automation station and pick and place. So screws are automatically picked up by the vacuum tube and placed onto the tightening point. So this is how it works. So this is what the additional thing it will have. So that is the important part for this one. As in the previous thing, in the previous machine we had a swivel type of mouthpiece at an angle, you can see in the left hand side figure. So this is how we need to check, and we need to select the nut runner systems according to the customer requirement and the automation requirement into the system. So this is all about nut runners. We have covered what the basics of nut runner, what are the different types, how to select, which factors affect the nut runner in our first series. So you can check out that in our second session. We covered how we can select nut runners for manual and semi-automatic machine, and in this session we covered like how we can select the complete system for fully automatic system. So if you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.